skill. Okay, so when we have something like this, parentheses x minus 3 squared, that means that you need to write the entire parentheses twice, right? Because it's the whole thing is affected. Exponent means you write it that many times. Okay, so from here, again, some of you I know still like to draw it this way. You certainly can do it like this. I prefer to do it with the arcs, but either way is fine. Okay, so x times x, x squared. X times negative 3 is minus 3x. Okay, so now this first x is done. It's already paired with everything over here. So we move on to the negative 3 times x is negative 3x. And negative 3 times negative 3 is plus 9. Okay, so x squared, and then these two in the middle combined, they're like terms. Negative 3x minus another 3x takes us to negative 6x. Okay. All right. So go ahead and try the other three in this section, please. Again, here's your example. Okay. So I went ahead and put up the answer so you can check and make sure you have it right. We'll be using this for the rest of the lesson, so it's important that you see that you did it correctly. Okay. So a little bit of vocabulary since we'll be using these terms. So a perfect square binomial, that will look something like parentheses x something squared. Okay, so it could be like x plus 2 squared, x minus 5 squared. I'll just give you an example. Let's just say x minus 5 squared, I guess. Okay, so it's called a perfect square because it perfectly turns into a parentheses squared, right? Remember the exponent of 2, we say squared out loud. And then it's called a binomial because there's two terms in the parentheses. Remember the minus sign splits it up, so you've got one term, two terms. Okay, and then just a reminder, we've defined trinomial as something with three terms, right? So that could be like ax squared plus bx plus c. Okay, so we're going to refer back to the warm-up because there's an important connection between these two forms of each problem. The perfect square binomial form with the parentheses and the trinomial form with no parentheses. Okay, so in order to help see that pattern, because once you have all your work, it's a little bit harder to find the answer. Okay, so for each box, I'd like you to please, underneath your answer, rewrite the perfect square binomial. Okay, so just take the original problem and write it below. Okay, so now you should have the trinomial form and the perfect square binomial form right next to each other. Okay, so let's try to find some patterns, right? Look at the top row, look at the bottom row of each box, and see if you can find, something that always happens, right? Some sort of connection between the numbers in each problem. So again, look at these, look at these. Okay, I'll give you guys a little bit of time to try to find some patterns, something that always seems to happen. Okay, does it, yes, a squared, you mean like this? Or
There's always a square root.
square root? So what's getting square rooted? You might be right. I want to make sure you're looking at us at which part?
Like, like every time we solve,
Uh-huh.
to get the answer, always in the answer, there is like a square root. Also in the problem, there is like a square root.
Okay, so square root is this symbol, right? So the squared. Okay, yeah, so you're right. These all have an exponent of 2. That's true. Okay, good. Any other patterns? Yes, Ben? The number in the parentheses. Okay, so Finn said that the b value, which is the number in front of the regular x, that's always double the number in the parentheses. Okay, so -6 is double -3, 14 is double 7, -12 is double -6, and 20 is double 10. Okay, so yeah, that's good. So we could also do it the other way, right? We could also say that this number is this number divided by 2. Okay, so that's the way that I'll phrase it. But yeah, the b value divided by 2 equals the number in the parentheses. Okay, so that's the first pattern. There's more than one. Okay, so that's our first pattern. And then Rubaiyat said that every problem has a squared in it, right? An exponent of 2. So if we look at the problem, that number in the parentheses, if you square it, like 3 squared, that gets you the 9, right? And then over here, 7 squared is 49. -6 squared, negative times negative is positive 36. 10 squared, 10 times 10 is 100. Okay, so once we know the number in the parentheses, we square it or we multiply it by itself to get the C value. Okay, so that's our second pattern. Okay, so again, C is the constant term in the trinomial, the version with no parentheses. Okay, so down here we sort of have like little puzzles. We have an equation, right, with an equal sign, but there's unknown numbers on both rows, right? So you need to fill in both rows to make it true. Using the patterns that our classmates just mentioned, we can do this very easily. Okay, so again, first using Finn's pattern, you said you always divide the b value by 2 to get the number in the parentheses. So for this problem, we will divide the b value of 10 by 2. So 10 divided by 2 is +5, so it'll be a +5. Okay, a common mistake is students divide the whole 10x by 2 and they write 5x instead. That would not be correct because then these would combine. They would be like terms. So remember, b is just the number. doesn't include the x. Okay, and then now using the other pattern that Rubaiyat noticed, that you always have a squared, to now fill in this blank, which is the c value, you take that parentheses number and you square it, right? So we do 5 squared. So 5 times a second 5 would be positive 25. Okay, so yeah, that's the pattern. You take the b value, divide by 2 to get the number in the parentheses below. Then you multiply that number in the parentheses by itself, or you square it to get back up in the row above. Okay, so yeah, normally you work top to bottom, but here you sort of start at the top, you go down to the row below, then you go back up to the row above. Okay, so go ahead and try to do the other 3 boxes using the same pattern. All right, so just thank you. If you weren't able, all right, Johnny and Michael, you guys don't need to be talking to each other right now. Thank you. Neither of you. Thank you. That's enough from both of you. Okay, so for this problem, we would divide the negative 8 by 2. So down in the parentheses is negative 4. And then we take that negative 4 times itself. So negative times negative is positive. So I want to write plus 16 over here. Make sure you do put the plus sign. Don't just write the number. You need the symbol between them. Over here, you would divide negative 2 by 2 to get minus 1. And then you take that minus 1 times itself to get plus 1. And over here, even though 5 is an odd number, you would still divide it by 2. Okay, so some of you did fraction, some of you did decimal. Either one is fine. For this one, I'll do decimal, I guess. So 5 divided by 2 is 2.5. Then you take that answer times itself, and that becomes positive 6.25. Okay, so this is going to be one step in the overall process that we're learning today called completing the square. Okay, so any questions on this side? Okay, go ahead and turn to the second page then, please. Okay. All right, guys. So why are we learning a new method, right? Last couple classes, we were doing solving equations by factoring. Why can't we just do that? Well, we've learned in the past that not all equations are factorable, or not all expressions are factorable, I should say. So if you try to factor this problem, 2x squared would have to be 2x times x, plus 7 at the end. They would have to be 2 minus signs, right? If you try like 7 here and 1 here, it doesn't work. You get minus 9x in the middle. If you try switching these, it would become 2x times negative 7 is minus 14x, minus 1x, that'd be minus 15x in the middle. So this is not factorable. So up until today, we would have said, oh, like it's impossible or there's no solution. But there actually is a way to get the answer. We just need to learn a new method. Okay. Yeah. Not the midterm, but it'll be on the unit 3 test later. Yeah. So yeah. So yeah. So just let me recap. Yeah, the midterm, which again announced yesterday, is going to be next Tuesday, is units 1 and 2 combined, and again, it's your opportunity to replace your unit 1 and unit 2 test scores. Again, the expectation is that you guys are studying on your own time. Unfortunately, we have to cover other material, so we can't spend too much time reviewing together. But All the resources are posted on Canvas for you guys to be studying on your own. Okay, so continuing today's topic. So step one, for an equation where you have ax squared plus bx plus c equals 0. So this is going to be kind of the opposite of what we wanted for factoring. So step one is move the constant to the other side. Okay, so remember last class we said that, oh, we need it to equal 0 because the zero product property says that factoring only works if it's equal to 0. But with today's method, we want to move the constant, the term with no x, to the other side. So to move the 7 over, because it's currently a plus 7, we do the opposite. We subtract 7 from both sides of the equation. Okay, so we've moved the constant over. Okay, second step. Okay, so again, let me just write a reminder, right? We know that the standard quadratic is ax squared plus bx plus c equals 0. Okay, so if the coefficient of x squared, if it's not invisible 1, we're going to factor it out. And this part's different. Previously, when we factored by GCF, by greatest common factor, we could only do it if the number went evenly into all terms. Okay, but for this problem, for this method, you always bring the a in front of parentheses, even if it creates fractions in the other part of the problem. Okay, so this first example, we won't have a fraction yet, but in future problems we might. Okay, so looking at this, for this problem, a is not invisible 1, it's a 2. So we do need to take the 2 out. Okay, so you bring the 2 out front. 2x squared divided by x, sorry, 2x squared divided by 2 is now just x squared. Negative 12x divided by 2 is negative 6x. We do not divide the other side because we are factoring, not dividing. Okay, so that was the reason we moved the negative 7 over earlier, so that we don't have to divide it by 2. When you factor, you only change one side, not both sides. Okay, so now we're going to make the problem look like what we were doing on the front page. Okay, so the reason the method is called completing the square is because currently it is not a square. You need to complete it. You need to add in a certain value in order to form a square. Okay, so that's what the blank will represent. Okay, so on the left side, the blank goes inside parentheses. On the right side, it can just go at the end. Okay, so this part should look familiar, right? This thing with the blank, because this is exactly what we did on the front page, right? Like over here, right? We started with these, and then you had to figure out the blank. So in order to figure out this C value, we first jump to the perfect square binomial on the row below. Okay, so in order to figure out this, we're going to jump to the next row first. Okay, so next step. Okay, so just like we did on the front side, whatever b is, whatever the coefficient of x is, divide it by 2. Yeah, I'll phrase it like this. Okay. So again, this one's going to look kind of tricky. This step is maybe the toughest one to understand at first. Okay, so we're going to keep this outside 2, but our goal is to rewrite this trinomial as a perfect square binomial. Okay, so again, if we look at the front side, as again Rubaiyat noticed, the squared moves to the outside of the parentheses, right? It used to be on the x squared, but that squared moves to the outside. Okay, so that's what we're going to do here. So we're still going to have parentheses, but instead of it being x squared on the inside, you'll still have the x, but this squared will move to the outside. Okay, so this is going to change it from a trinomial to a perfect square binomial. Okay, and now we can do what we did on the front page, right? We said divide the current b value by 2. So -6 divided by 2 would be -3. Okay, and then it's the same thing we did on the previous page, but I'll just write it again. Okay, so whatever number you got from that previous step, multiply that number by itself, meaning square it. Okay, so you take that number, you multiply it by itself, and that fills in the blank above, right? Because remember, we were on this highlighted row, then we jumped down to the row below, but now we got to go back and fill in the remaining blank. Okay, so you take that -3, you multiply it by itself. Negative times negative becomes positive. Okay, so before we continue, let's just take a second to make sure that we're all caught up. Are there any questions on what we've done so far? Okay, so an important thing to understand is we have changed the left side from how it started. Okay, so if you compare this row that I'm pointing at to the row below, this +9 didn't used to be there, right? So we've made the left side worth more than it was before. So we need to balance it out. In order to keep the equation balanced, we need to add an equal number on the other side, right? We always know that if you do something to one side of the equation, you have to do it to the other side. Okay, now here's maybe the other part where the most mistakes happen. We want to balance the equation by doing the same thing to both sides, but we're actually not going to write +9 in this blank like you probably expect. I'll just throw it out there. Does anyone think they know why +9 is not the way to balance it or what we should do instead? Good. Good thought, but that also wouldn't work because because you're doing it to opposite sides, if you added 9 to the left and subtracted 9 to the right, that would not balance it. Yeah, so the reason is, if remember, anything that touches parentheses gets distributed out. So even though it looks like a plus 9, it's actually worth 2 times that. The blank plus 9 is getting multiplied by the 2. Okay, so actually 2 times 9 is worth 18. Okay, so to balance it out, we have to add 18 to the other side. Okay, so yeah, any number in front of the parentheses multiplies the blank, and that's the total value. So that's what gets added to the other side. Okay, so I'll write that step in words. Okay, so yeah, if that blank that we just filled out, if it had a factored out number in front, okay, so again, if that blank had a factored a in front, you multiply them together. Okay, and that value is what goes on the other side of the equal sign. Okay, so let me do the last couple steps again so that you can see it sort of all flowing together rather than as, one step at a time. Okay, so we started with this, right? We had two blanks, one on each side. Okay, so first we focused on the left side only. We ignored the right side. We said, okay, we take the -6 divided by 2 to get -3. Then you take that -3 times itself to get +9. Okay, so now because we added a 9 out of nowhere on the left side of the equal sign, we need to balance it out on the right side. Right, but that 9 is actually worth more than 9 because it's multiplied by the 2. So 2 times 9, it's actually worth 18 on the other side. Okay, so even though the numbers in the blanks are different, they're worth the same because 2 times 9 matches the 18. Okay, so let's go ahead and just simplify the right side. These are just numbers, so we can combine them together. -7 plus 18 would be +11. Okay, almost there. Next step is to get the parentheses by itself. Okay, so when we say by itself, we mean nothing in front and nothing behind. So right now we've got a 2 in front of the parentheses. The 2 is touching the parentheses, so that means it's multiplying it. So the opposite of multiplying would be dividing, right? So to undo the 2, let's divide both sides by 2. Okay, so I'm going to leave this one as a fraction. We could do a decimal, but sometimes you have to keep it as a fraction because the decimal goes on forever. So I just want to show you what it looks like as a decimal. Okay, so we're almost there, right? The x is almost by itself. We cannot undo the -3 yet because it's protected by the parentheses. So first we need to undo the exponent of 2. Okay, so here's the last tricky part, the part where a lot of mistakes happen. To get rid of the squared, you do the opposite, which is called a square root. Okay, so the important thing to understand here is that you need to put this symbol called a plus minus sign in front of the constant. Okay, so how that looks on our problem. So we're going to square root both sides. We're going to draw a big radical over both sides. You want to do it a separate radical, one on the left, one on the right. The whole point is that on the left, the square root and the squared cancel out, leaving the x minus 3 behind. Okay, over here, this doesn't simplify, right? Square root of 11, what number times itself equals 11? No number that we know of. So we're going to leave this one in the square root, but we need to add the plus minus sign in front of it. This plus minus means it can either be positive square root 11 over 2 or negative square root 11 over 2. Okay, so let me explain the reason that we need a plus minus sign. Okay, so here's a separate problem, but let's just say I told you that x squared equaled 16. So when you square root both sides, right, up until now, we've always said, oh, 16 is 4 squared, right? So you think 4 is the answer because 4 squared does equal 16. But -4 would also work, right? -4 squared, -4 times -4, that would also equal 16. So since both +4 and -4 work, we need to put the plus minus sign. Okay, so this is true no matter what number the x squared equals. You always put the plus minus sign. Okay, so that's why over here, again, even though the radical doesn't simplify, you put the plus minus sign. Okay, and then we're on the very last step. Okay, so last step is to get the x by itself. So right now, the x is not by itself. It's got this -3 attached to it. So the opposite of subtracting 3 would be adding 3 to both sides of the equal sign. And the whole point is to cancel those out, leaving the x by itself. Now over here, you can't add a regular number to a square root. Okay, so what you do is you just put this number in front and you copy this part, including the plus minus sign. Okay. Okay, so yeah, this answer is actually two different answers. You could do the plus sign, or you could do the minus sign. Okay, so yeah, the plus minus, you should understand, represents two different answers. So you're allowed to leave your answer like this. You can just leave it with the plus minus sign, but it's important to understand that, again, this is actually two different answers. There's the plus version and there's the minus version. All right. So again, that one, we sort of went back and forth between the words and the problem. So let's go ahead and do a problem all the way through. Okay, so let's go to the third page. Okay. So let's go ahead and look at this one. So again, you can thank you. So again, you guys can maybe leave your paper unfolded so you can still see the second page also, because we're going to go through the exact same steps. Okay, so step one, right, was move the constant to the other side. So to move the plus 6 over, we will subtract 6 from both sides. Okay, so step two, we said if A is not invisible 1, we need to factor it out. So very good. Here A is -1. So we do need to factor out the negative sign. So you can write -1 if you want, or you can just draw the negative sign. So negative x squared divided by a negative, negative divided by negative is positive. But over here, 5x divided by a negative switches to -5x. Okay, remember, you do not divide the right side by -1. When you factor, you only affect one side. Okay, next we add a blank to both sides. So on the side with the parentheses, you put it inside the parentheses. Okay, so the next step, right? In order to figure out the blank, we need to first jump to the row below. So you keep the negative in front, and you still have parentheses, but remember, the exponent of 2 will move from the inside to the outside. Okay, so it becomes regular x on the inside, and the exponent moves to the back on the outside. And then to figure out the number in the parentheses, you take the b value and you divide it by 2. Okay, so -5 divided by 2. This time, let's go ahead and use decimal. -5 divided by 2 would be -2.5. Okay, and now that we know that number, we can go up and fill in this blank. You take that number times itself. Okay, so again, you're welcome to use a calculator. You are allowed a calculator on the test. -2.5 times -2.5 will be positive 6.25. So plus 6.25 goes in this blank. Okay, but again, it's different from the row above, right? We added this number out of nowhere. So to balance it out, we need to add something to the other side. But remember, it's not always the exact same number, because you need to remember that the factored out A value multiplies the blank. Okay, so the negative on the outside multiplies the plus 6.25. So negative times positive is negative. So it's going to be minus 6.25 on this side. Okay, so using a calculator, we can just go ahead and combine those two together. -6 minus 6.25 would be -12.25. Okay, next step. we want to get the parentheses by itself. So that negative in front, we can get rid of it by dividing both sides by a negative. Okay, so we get parentheses x minus 2.5 squared equals positive 12.25. Remember, we can't undo the minus 2.5 yet because it's protected by the parentheses squared. So to get rid of the squared, we do the opposite, which is square root. Again, the whole point is that the square root and the squared cancel each other out, leaving just the inside. But on the other side, it doesn't cancel out because there's no squared. So here you actually do the calculation. You do the square root of 12.25. Okay, so this would be very difficult without a calculator. So let me show you how you would do that. All right, so you've got probably a square root button above your x squared button. Sorry, let me zoom in a little bit. Yeah, so above the x squared button, I hope we can see there's a little blue printed on the back the square root. Right, so we do second that button to create the square root, and then we just type in 12.25. So the square root of 12.25 is 3.5. But here's where we need to remember to add the plus minus sign. Right, because if you do negative 3.5 times itself, it also equals 12.25. Okay, and then the x is not quite by itself yet. It still has this minus 2.5. So let's add 2.5 to both sides. Okay, so notice the order kind of gets switched. The 2.5 goes in the beginning, the plus or minus goes at the end. Okay, so last problem, we just stopped right here. I said you could leave the plus minus sign. The reason is that you can't add a regular number to a square root, right? So even if we split it up, we can't do anything with those two numbers. They don't combine. But when both numbers become regular numbers, when the square root goes away, then we do want to split it up. Okay, so again, one version is the plus sign, and the other version is the minus sign. Okay, so now we can actually add them together. 2.5 plus 3.5 would be 6. And over here, 2.5 minus 3.5 would be -1. Okay. So questions on this one? Okay, let's try one more together. Find the roots of this. Remember, roots means y equals 0. Okay, so first step, add 9 to both sides to move the constant over. Second step, a is not 1, it is 5, so we need to factor the 5 out. Remember, this only affects the left side because you're factoring, not dividing. Okay, add blanks to both sides. Again, that's why it's called completing the square, because you need to complete whatever is missing. in order to figure out the blanks, we jump to the row below, keep the outside 5, but on the inside, you're going to move the squared from the inside to the outside. Okay, for this problem, b is invisible 1. So we divide 1 by 2. Let's do decimal this time, plus 0.5. And now that we know that number, you go back up here by multiplying it by itself. 0.5 times 0.5 is 0.25. Okay, so the other side, again, it's not going to be plus 0.025. It's affected by the 5 over here. Okay, so 0.025 times 5 is 1.25. Okay, so again, you often will not add the same number in both blanks, but they're actually worth the same. You just need to remember that the blank in the parentheses is multiplied by whatever's in front. Okay, 9 plus 1.25 would be 10.25. Okay, we want to get the parentheses by itself, so we need to get rid of this 5 in front that's touching the parentheses. So opposite of multiplying by 5 is dividing by 5. Again, you can use your calculator for this part. Okay, so now how do we get rid of the exponent? We square root both sides. On the left side, right, the whole point is to cancel out the parentheses squared, leaving the inside behind. Okay, and let's see what happens when we use our calculators for square root of 2.05. Okay, so square root of 2.05. Okay, so this one does not simplify nicely. The decimals go all the way to the edge of our screen. So that means that this square root does not simplify. So instead of using the new decimal, we're going to leave it inside the square root. Okay, so again, we're just going to leave, oops, sorry, wrong one. We're going to leave the right side as the square root of 2.05. But we do need to add the plus or minus, because even though we don't know the specific number, we do know that both the positive and negative versions would work. Okay, and then very last step, to get rid of the plus 0.05, you would subtract 0.05 from both sides of the equation. Okay, so for this problem, we do not need to split it to the plus version and the minus version because there's still a square root symbol. That means there's no way to add them together. Okay, so yeah, there's our answer. Okay, it's, again, all the same steps that we wrote on page 2. It looks like a lot of steps, and it is a decent amount, but like anything, the more you practice it, the more you'll be comfortable with it. Okay, so why don't you go ahead and try the practice problems below.